Okay. So I'll read it first, and then I'll go back and dissect information that you should be able to grasp. I chose these specific examples because there's questions on your homework that should reflect each and every one of these. So in number 1, a group of friends agrees to equally share the cost of a $50,000 yacht. Before the purchase is made, though, one more person joins the group and enters the agreement. As a result, each person, their share is reduced by $2,500. So they were going to split the cost between a certain number of people. If you add an additional person in there, right, everyone's cost goes down. So how many people were there in the original group? So on the forefront, you're like, I have no idea. You'd probably start guessing and checking, right? But we want to do this algebraically. So starting with your $50,000 yacht, we're going to take that price and we're going to divide it between X people. So X equals the number of people. So there's the first thing we don't know. And then once you take that dollar amount and divide it by that number of people, you're going to get some amount that each person is going to pay. So Y is going to be the price per person. I'm just going to use a dollar sign. So there's your initial equation. But then the equation changes because someone else joins the group. Right now we already have 2 unknown variables. There's no way to solve for 2 unknown variables unless you have 2 separate equations. So we have to write a separate equation for how this scenario has changed. So if we added a person, now what is the 50,000 divided by? Very good, X plus 1. And if each person's share is reduced by $2,500, what does this all equal? Very good. And then we have a system of equations. We've got 2 equations with 2 variables. Quick review on systems. You solve them by substitution or elimination, right? You know those 2 techniques. If you already have a variable all by itself, substitution is the way to go. Okay, so since Y already equals 50,000 divided by X, I'm going to plug that in for Y over here. So I have 50,000 divided by X plus 1 equals, and I'm substituting in 50,000 divided by X minus 2,500. Now, since we don't often have a calculator, I want to jump on the opportunity to simplify these large numbers as right now before I get into anything more confusing and have to write down more zeros than I'd like. So if you look at your 3 numerators, what can I divide out of all of those? 100? We can start there. If I divide out 100, that's just going to cancel 2 zeros from everything.
I said 25.
Oh. You said 2,500? Okay. Well, if people just want to get rid of the zeros first, they could. Then they've got a 500, a 500, and a 25. Out of which, Nick is correct, you can now factor out another 25, or divide out another 25. So 500 divided by 25. 25 goes into 50 twice. And then add the 0, so that would be 20 over X plus 1 equals 20 over X minus, and I'm dividing out of 25, so it's just going to be 1. And then this rational is much easier to solve. So I'm just going to continue with the clearing fractions method. The least common denominator would be X plus 1. So both sides are going to get multiplied by X plus 1. On the left-hand side, when I multiply this, the X plus 1s are going to cancel, and I just have 20X. On the right-hand side, when I distribute, my x's are going to cancel, and I'm going to have 20 times x plus 1, which we can distribute to 20x plus 20 right away if we want, minus, and when I distribute here, this is just going to be x squared plus x, but there's a minus sign in front of it, so be careful there. Keep parentheses around it, x squared plus x. Now that the rational equation is gone, what kind of equation is this? Quadratic. So I'm just going to kind of distribute and get everything equal to 0. So do you see the 20x's on both sides? Good, they're gone. Subtract 20x over, that's gone. So 0 equals negative x squared minus x, because I'm distributing that minus, plus 20. Now I'm sure you all, just as much as I, hate the negative in front of the x squared. So I can switch all those signs. Technically I'm dividing both sides by -1. So I'm switching all the signs to positive x squared, positive x, and minus 20. And then this is factorable. Who can tell me the factors? Very good. X plus 5, x minus 4. So x equals negative 5, x equals 4. X stood for what again?
People.
Number of people. So the negative 5 people doesn't make any sense, so we're going to reject that. And x is 4. So how many people were originally in the group? 4. Questions? Any steps that I may have lost you at? Nick?
Will we ever have to do like a therefore statement?
No. Alright, so that's one type of question you're going to see where it kind of caters to a system, and then the system creates a rational. It's pretty ugly, to be honest, but once you see that, now if you see something like that to that effect, kind of use this as your model until you're more comfortable with it. Okay, number 2. A wheelchair ramp with a length of 122 inches has a horizontal distance of 120 inches. I like pictures. So here's my ramp. There's my horizontal distance. There's my vertical distance. The ramp is 122 inches. The horizontal distance covered is 120 inches. What is the ramp's vertical distance? What am I going to have to do here? Pythagorean theorem. Now, on your homework, like at this on this problem, you're going to have to use a little bit of judgment and use our notes as a guide as to when a calculator is going to be okay. Like I just taught you kind of a shortcut how to simplify this one so that we were able to do that without a calculator. Use that kind of shortcut. This one, when we're squaring 120 and squaring 122, you can use a calculator. Okay? So subtract the 120 squared over, and then 122 squared minus 120 squared. 484. So x squared equals 484. Square root both sides. X equals plus or minus 22 technically when we're solving just an equation, but we would reject the negative for the obvious reason that the ramp isn't negative 22 inches tall off the ground. So x would equal 22. So the problem continues and says that construction laws are very specific. Every vertical rise of 1 inch, and we have 22 of them. So every 1 inch here has to require a horizontal run of 12 inches if it's going to be up to code. Okay? So every one of these 22 inches, so these 22 inches, has to have a horizontal run of 12 inches. And 22 times 12 is 264. Is this ramp up to code? No, we don't have the 264 that we need. It's way off. So the answer would be no for that follow-up question. Any questions, comments here? Okay. Number 3 talks about a rectangular garden that measures 80 by 60. Again, I like my pictures. 80, 60. A large path of uniform width is to be added along both shorter sides and one of the longer sides. So we're going to add a path in on 3 of the 4 sides. Both shorter sides and one of the longer sides. And that path is of uniform width, which they don't tell us how wide it is. That's exactly what they're going to ask for. So this width here is X. That's how wide our path is. So that means this is X here, that width, and on this one, this is X here. The landscape designer wants to double the garden's area when he adds the path. So what is the current area? What is it? 4,800, right? 6 times 8 is 48, add your 2 zeros. So there's the current area. He wants the area to be double. So what does he want the area to be? 48 twice is 96. So when we're trying to find the area of the overall space, once that path is added, we want it to be 9,600. What is the new length of that whole space? The new length, 80, the original 80, plus an X here, plus an X there. So the 80 plus 2X is the new length, and what's the new width? 60 plus just one X up top. Okay, so the original 60 plus another X. And we want that to equal 9,600. So when I distribute through, I'm going to start with my 2x squared plus 120x plus 80x plus 4,800. We have a quadratic. We're going to get it equal to 0 and combine like terms. So we have 2x squared plus 200x. And then when we subtract 9,600 over, we get minus 4,800. What can I do here to simplify these numbers? Very good. Divide all by 2. I'm going to go up here. So that's going to make x squared plus 100x minus 2,400. If it was an expression and it said to factor, you'd keep your 2 out in front. If it's an equation, what I'm technically doing is dividing both sides by 2. So that those two all reduced, and then 0 divided by 2 is still 0. Okay, so no, you do not need to keep it. So factoring this one, raise your hand if you think you can do this without a calculator. Think about it. I think there's more of you than 2 of you. I think with a little more thought, you might. I'm seeing 4 hands. Nick, Hannah, John, Anna, Joseph, Lexi. Oh, it's getting better by the minute, by the second. Lexi, what do you think?
24 is a 10, like instead of all the zeros.
Okay, so do you know what it would, like, she's kind of treating the last term like a 24, thinking about that number and the 10.
So 12 and 2.
Okay, so we've got x and x for x squared, and she's thinking 12 and 2 multiply to get 24 and kind of have a difference of 10, right? We're going to have to play with zeros a little bit, but she's got the right idea. What would your exact numbers be?
120 and 20.
120 and 20, very good. Which is positive, which is negative?
120 is positive.
Perfect. So her outer is 120x, her inner is negative 20x, which gives you the combo of 100x, and then negative 20 times 120 is negative 2400. Perfect. Does everyone see how she kind of chopped off zeros and used that technique to think that through? And then played with it probably a little bit, trial and error. Somebody thought 60 and 40, which you can see why they might think that, because 6 times 4 is 24, and 6 plus 4 is 10. But with a 60 and 40, and one would have to be positive and one would have to be negative. And the difference between 60 and 40 is 20. We needed the sum of 60 and 40. So it doesn't quite work out. The signs wouldn't work out. So x equals 20, or x equals negative 120, and then think back the context of the problem. X was the width of the sidewalk. So get rid of your negative, and your answer would be 20 feet. Thought we were in inches for a second. We are in feet. Any questions on that? You should have done problems like this before, maybe not with the size of numbers that we're dealing with now, but does that kind of problem look familiar to anybody? Yeah, okay. All right. Number 4, there are a lot of ways. I'm sure we could all give this a try and come up with 3 to 4 different ways of doing it. I'm going to do it by writing an equation that kind of goes chronologically with the story. So, after a 30% price reduction, you purchase a new computer for $840. What was the computer's price before the reduction? So, what was the original price? You walk into the store, the price is X. We don't know. The discount minus that we're getting is 30% off of that original price. So that's where we subtract 30% of the original price. And then the payment we're making equals $840. Does that make sense? Kind of that logical flow, chronological flow? Now, I'll get to you in a second, Nick. From here, we would just solve combine like terms. So this is technically 1x minus 0.30x would be 0.70x. And if you're in the middle of a store and you're trying to do this in your head, this might be where people start. At least I know if I know that there's 30% off of something, my logic is, okay, if I'm getting 30% off, then I'm actually paying the rest, the 70% that's left. Does that make sense? So instead of trying to come up with 30% and subtract that from the original, because that's 2 steps in my head, I'll instead think, okay, if I'm getting 30% off, I'm paying 70%. So I'll figure out what 70% of the original price is. Does that make sense? A little mental math there? All right, now Nick, what were you going to say?
I was gonna say, when I put it at .7.
So you were going to start right there. Yeah, and you can. I just kind of wanted to write the whole picture. Tori? Yes. So when I divide by .70, maybe right now you're not, but we're working on your non-calculator skills. This will definitely help you for your SAT as well, because there are non-calc sections now, right? So hopefully you become more comfortable without it and don't have a panic attack that you don't have your calculator on the SAT. First of all, dividing something, a whole number, by a decimal can be a little bit frightening. But the technique that you probably don't remember, but that you should have learned at some point, is make this so it's not a decimal. Move that decimal place over once, so it's just dividing by 7. And to counter that, you have to move this decimal place over once. So really, it's 8,400 divided by 7. That'll take care of your decimal fear right there. And then how many times does 7 go into 84? 12. But you have to tag on your 2 zeros. Does that make sense? So, not only does the process make sense, but think logically, does the answer make sense? Does it make sense that the computer's original price would be $1,200, and you got it on sale 30% off for $840? Yeah, that's a good ballpark, right? Tori, you initially said $120, right? Mm-hmm. But when you logically think about that, was the computer ever $120, and then on sale you paid $840, you would realize, wait a minute, I must have missed a zero or something small somewhere. Okay, so on top of, because right now you're sort of learning how to do more and more in your head, so once you have an answer, think logically about it in the context of the word problem. Okie doke. Flip her over. In 1954, Roger, are we all familiar with Roger? No, me neither. Now we are. Roger Bannister of Britain cracked the 4-minute mile mark, coming in at 3 minutes and 59.4 seconds. Okay? So that was the world record in 1954. In the half century since, how long is a half century? 50 years. About 0.3 of a second per year has been shaved off his record. If this trend continues, by which year will someone run a 3-minute mile? So, again, chronologically, let your equation tell the story. The world record is currently this, or in 1954 anyway, was currently this. So that's the time we're starting with. And then we're shaving off 0.3 of a second per year. Now, we have to get this all in the same units, right? So, given that we're losing 0.3 of a second per year, I don't really feel like changing 0.3 of a second into minutes is really the way to go. Instead, I'm going to change my minutes into all seconds. So 3 minutes is 180 seconds plus the 59.4. That's close to 60, right? So 180 plus 60 is 240, but I'm just shy of that. It's 239.4. So that's where the world record was, 239.4 seconds. We are shaving off 0.3 of a second per year. And we're waiting until, trying to figure out how many years that's going to take until this new world record reaches a 3-minute mile, which is 180 seconds.
So was the half-century information just like...
Fluff, yeah. And me asking you what a half century was just to put context to it, 50 years, like processing that. So then we're just going to solve this. So subtract 239.4. So I know this is going to be a negative number. And then I really just need the difference between 180 and 239.4. So again, to get from 180 to 240 would be 60, but I'm just shy of that, so it's 59.4. And then divide both sides by negative 0.3, and y equals. Here we are with the decimals again. So I'm going to treat this as 594 divided by 3. Good?
Yep.
Now, I don't know that in my head, so I'm going to give you a quick recollection of long division, which you did last year with polynomials. The process is very similar. 3 goes into 5 one time. Multiply that out, you get 3. Do your subtraction. You're left over with 2. You bring down the 9. Do you remember this? Yeah.
Should the 180 minus 239.4 be 59.6?
Yeah.
Yeah.
If it's empty.
$180 to $240. I kept thinking this in the first class today. $180 to $240 is 60. No, it's negative 59.4. Yep. I just checked it on my calculator as well. But I see why you're second guessing that. Because I was doing the same thing this morning. But when you do subtraction, no matter which order you do it in, you're finding the difference between the two. The sign may flip-flop, but the difference to get from 180 to 239.4 is 59.4. Do you follow?
Yeah.
But I get why you're second guessing that. Ryan?
I did this a little differently. Instead of converting the 3 minutes to seconds, I just started with 59.4 minus 0.3 x equals 0, and I got the
Okay, which makes sense because you're just looking to shave off 59.4 seconds, really. So you're just doing 59.4 divided by 0.3 to see how many years it's going to take to shave. So you kind of found that difference between 3 minutes and 59.4 seconds and just the plain 3 minutes in your head. That's fine. Same thing. So 3 goes into 29, 9 times, 27, 2, 4, 3 times 8, 198. So 198 years, which would, make sure you answer the question, by what year? So we're 198 years after 1954. That's 2,152. Sam?
Isn't it 198 half centuries? So 50 years?
198 what?
198 half centuries, so 50 years?
Half centuries?
Yes.
No, we're still shaving off 0.3 of a second per single year. This was kind of fluff, to Hannah's point. In the half century since, they're just kind of telling you, in the past 50 years, here's the trend. We've been shaving off 0.3 of a second per every single year. Okay? All right? We're not going to do the last one. The last one, if we had time, I would have had you try that on your own anyway. It's very similar to number 1. So your homework, which is not written at the bottom, is what I sent out a remind text on. Yes? So you all have that? You all signed up for that? We're good?